Today we are going to learn how to solve compound inequalities. First, we are going to review multi-step inequalities, though. So, first, when we're dealing with inequalities, remember that when you multiply or divide by a negative, on both sides of the inequality, you have to flip the inequality symbol. If you have a less than or greater than sign, you have an open circle. If you have a less than or equal to or greater than or equal to sign, you have a closed circle. Open circle means that that number is not a solution. Closed circle, it means that it is. Inequalities may have no solution. And they might also have multiple solutions or multiple numbers as solutions. Alright, so first let's review how to solve multi-step inequalities. It would be the same thing as what you would do to solve a multi-step equation. So the first thing you want to do is distribute. So we have 28 minus k is greater than or equal to 7k minus 28. Okay? Doesn't matter if we bring the variable to the left or the constants. In this case, I will just take the variable over to the left. So we have 28 minus 8k is greater than or equal to negative 28. Subtract 28. Then we have negative 8k is greater than or equal to negative 56. Now, because we are dividing both sides by a negative number here, our inequality symbol will flip, so we now have k is less than or equal to 7 as our final answer. Please pause this video and try numbers 2, 3, and 4. When you are done, start it again so we can check the answers. Right, you should have paused your video, and it is now time to check our solutions. So here we would have 28 minus 7 x is less than or equal to 28x plus 28. We can bring the 28 over to the other side by subtracting. In that case, you're left with negative 7x is less than or equal to 28x. Now, we aren't done yet because we still want to get the variables on the same side, so we could subtract 28x here, and we'd have negative 35x, and we'd be left with nothing on this side. Now, if we divide by a negative 35 to get x alone, we're going to have to flip this inequality symbol, so we're left with x is greater than or equal to 0. Alright, number 3. Again, we have to first distribute, so we have negative 6 minus 42k plus 7 plus 42k is less than or equal to negative 2. Now we can combine like terms on the same side, so we have negative 6, and we have 7, which gives us 1, and then we have this negative 42k and positive 42k, which actually give us 0, so we aren't left with anything. So we have 1 is less than or equal to negative 2. Now, because 1 is not less than or equal to negative 2, 1 is not a solution. There is no solution to this inequality. So we are going to write that. Okay, the last one, we again are going to distribute, and we'd have negative 4 plus 4x minus 4x minus 20 less than or equal to 24. Again, we can combine our terms on the same side, so we have negative 4 and negative 20, which will give us negative 24, and then we will have 4x and negative 4x, and again those make 0, so we're left with negative 24 is less than or equal to negative 24. Because this is a true statement, we would have all real numbers as our solution. Alright, so now we're going to get into compound inequalities. Compound inequalities consist of two inequalities by an and or an or, connected by an and or an or. We have a conjunction, which is and. You'll see it in two ways, either with the x in the middle of the two inequality symbols or with the word and. This means that your solution has to satisfy both inequalities in order to be a true solution. To solve this, we're going to solve from the middle and work out. And the goal is to isolate x in the middle. So let's try this example here first. So the first thing we would want to do is add 8. And we'd be left with 6 is less than or equal to 3x, which is less than 18. And then we can divide by 3. And we get 2 is less than or equal to x, which is less than 6. Now we can write that in two ways. We can write it in, or the solution two ways. We can write it in set builder notation. So we have the set of all x such that 2 is less than or equal to x, which is less than 6. Or we could write it with the and, so we could have the set of all x such that x is greater than or equal to 2 and x is less than 6. In interval notation, we'd have a bracket because 2 is a solution, and then we'd have 6 with a parenthesis because 6 is not a solution. Now, if we wanted to graph this, we would make our number line. We want to start by graphing both inequalities. So let's graph x is greater than or equal to 2. And let's graph x is less than 6. Now when we work with the conjunction and the inequality has to, or the solution has to satisfy both inequalities, so we're looking for where the inequalities overlap. And that would be in between the 2 and the 6. So we would include this 2. So we'd have that closed circle. And then we would have an open circle at 6, because 6 is not included in one of the solutions. So the only part that we would graph would be this purple part right here in the middle where both of those inequalities overlap. So now let's look at if we have a disjunction, which is or. That means that the solution has to satisfy one of the inequalities, but it does not have to satisfy both. So we are going to solve both sides of the inequality, and then we'll look at graphing it. So we'd have 3x minus 3, which is x is less than 1. And then we can solve the other one. We have 2x is greater than or equal to 12, which means x is greater than or equal to 6. So we know that the solution has to either satisfy the inequality x is less than 1, or it can satisfy the inequality x is greater than or equal to 6. So if we write that in set builder notation, again, we would write the set of all x such that x is less than 1, or x is greater than or equal to 6. And in interval notation, we are going to write the solutions for both inequalities. So for x is less than 1, we'd have an open parenthesis, negative infinity to 1 with a parenthesis, or would have a bracket for 6 to infinity open parenthesis. Right, so this graph is going to be a little bit different than if we were looking at and. We would have our number line. And again, we're going to graph both inequalities. So we have 1 is, or x is less than 1. Or we have x is greater than or equal to 6. Because the inequality can satisfy one or the other, we can leave the graph just like this with the two inequalities graphed. Alright, so pause this video and practice 1 through 6. Try solving and graphing, and then start the video back up so we can go through the answers.